Hello, welcome back. As I told you, I'm all alone here, so I can teach without having to wear a mask. But if you're in a classroom, if you're in a group, please do wear your mask and please maintain the distance. Thank you. My name is Susale Mohana. In the past 7, 8, almost 10 lessons, we have been discussing and looking at various aspects of trigonometry at A level. I've come to a stage wherein I had to start radian measure. I had told in the last lesson I'll start radian measure, but I decided to do a couple of questions. Of course, I'm not going to write any of the formula. I expect you either to know the formula or you have, as I requested you, a memory card or a sheet of paper where you have all the formulas. So when I work the question, you'll be able to refer when I quote a formula. Otherwise, I'll spend more time writing the formula than helping you with questions. These are questions I've made up. I don't know whether they are examination type of questions or not, but I think they do come. They can come in the exam. Let me put it that way. They are well within the purview of any A-level syllabus of UK, and it might be useful to children doing maths at higher level, like 12th standard in India and USA, Canada, and other countries, as I keep repeating like a parrot. Okay, let's start. So we are still in topic 5. We're doing trigonometry. What I've done is I have listed or worked out or prepared a set of questions in the same order: single angle, double angle, compound angles, double angle, T formula, A cos X, B sine X. Yeah, I have left out sum and product rule because it's not very common as far as Edexcel is concerned. But if I feel like I might show you 2-3 questions on that as well towards the end, I can make up on the spot. So let's start with these are revision questions. Revision of formulae learned. Using questions. I think this is going to be 2-3 videos, so I'll put it as number 1, then I might do number 2, I might do number 3. I hope I remember the numbering. I'm very poor at remembering those things. Let's look at the first of the questions which I have made. If sine A equals 3/5, find the possible values. See, each question on its own may not be much importance, but concept behind will be useful as you tackle questions from your textbooks, from past papers and so on. Find the possible values of cot A and sec A. I could have given tan and cos. I just made it a bit more complicated. Okay. Now, remember ASTC. You know sine is positive. That means there are 2 possibilities. One is it's here or it is there. So draw 2 separate diagrams. That is A, that is 3, that's 5, that's 4, or that is A, that is 5, that is 3, that's -4. So the values of cot A, what is cot? Cot A is 1/tan A, which would be adjacent over opposite. Adjacent, so 4/3 or -4/3. Or I can say plus minus 4/3. Sorry, I forgot to turn on the stopwatch because I don't want to go beyond 20-22 minutes maximum. Alright. Sec A is 1 over cos A, or it is hypotenuse over adjacent. 5 over 4 or minus 5 over 4, which is plus minus 5 over 4. So in the exam, it says possible values. So you need to consider, in other words, you need to remember where sine can be positive, where tan can be positive, where cos can be positive, ASTC. Alright. The next one is, of course, similar questions. I'm not going to give any handout. You can use this as a reference and pick questions from your textbooks and revise. Otherwise, I'll be spending 3.5 hours typing about 15 questions because the theta, the square root and the square and the pi and the limit, I don't have the time. Instead, I could use it for something else, teaching you more topics. Eliminate theta. This pen is giving up. I don't know why. Okay. Eliminate theta from part A. X equal to sine theta plus cos theta. Y equal to sine theta minus cos theta. That means I want a relation between x and y without a theta. You might be wondering suddenly, sir, look, I think it is sine squared theta minus cos squared theta when I apply, but sine squared theta minus cos squared theta is not 1. It is minus cos 2 theta. You still have a theta. So it's a bit difficult. Whereas I know sine squared plus cos squared is 1. Meaning, if I know what is sine, if I know what is cos, I could use sine squared plus cos squared, right? So what happens when you add? Why did I do that? Because I know by adding I can find sine theta. 2 sine theta equals x plus y. So sine theta equal to x plus y over 2. Clever, isn't it? I got sine theta. Suppose I subtract. What do I get? 2 cos theta equals x minus y. So cos theta is x minus y over 2. Now I know sine squared theta plus cos squared theta equal to 1. So x plus y whole squared plus x minus y whole squared over 4 equals 1. It's pretty interesting. X squared, or multiply through by 4, x plus y whole squared plus x minus y whole squared is equal to 4. You might be wondering, sir, why are we doing this? When you do parametric equations, the question could as well be, if x equal to sine t plus cos t, y equal to sine t minus cos t, 0 less than t less than pi over 2, show that the Cartesian equation is blah 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 blah. That's why. So it is x squared plus 2xy plus y squared plus x squared minus 2xy plus y squared is equal to 4. The 2xy's can be cancelled. 2x squared plus 2y squared is equal to 4. X squared plus y squared equals 2. Now, how would this question come in the exam? In parametric equations or even in coordinate geometry, they might say, given that x equal to sine t plus cos t, y equal to sine t minus cos t, show that this represents a circle, center 0, 0, radius root 2. Can come? Then this is exactly what you do. That's the purpose of eliminating. So in other words, a circle, center 0, 0, radius root 2. Get that? Clever, isn't it? Hey, I made up this question. Can you imagine? Ooh, I'm clever. Alright? Let's look at another question. This you might find it as a part of some work. Find exact values of part A sine 1065, part B tan minus 810. Well, the purpose of this is to revise how to find ratios of angles more than 90. 1065, look, 90, start with 360. 360 times 1, 360. 360 times 2, 720. 360 times 3, 1080. So this is 1080 minus something. So you can do it this way as well. So it's like this. 360, 720, 1080, 1065 would be there, isn't it? It's basically 15 degrees less. Yeah. So it's in that quadrant. So, but who's going to draw all these diagrams? No, don't worry. Remember, I taught you divide by 90. So 90 times 12 is 1080. So it is sine of 90 times 11 minus 15. No. 1080. 1080 divided by 9. 9 1s are 9, 118, 120. So it is 90 times 120. No, that can't be. Oh, it's 90. So 90 times 12 minus 15, not 11. That's correct. 12 is an even number. So sine remains sine. And then I think I should make it 1080 minus 45, 1025. No, 35. Because I want exact value. So 12 is an even number. 90 times 12 is 1080. Anyway, it is 90 times 4, 90 times 8, 90 times 12 minus. So you are in the fourth quadrant. In the fourth quadrant, it is minus. It's an even multiple of 90. So remains sine and the angle is 45. Which is minus 1 over root 2. Let's look at that. Minus 810 plus 60, 870. Fine. So 90 times 9 is 810. So it is tan of 90 times 9 minus 810 minus 60, or tan of 90 times 10 plus, no, 90 times minus 9, 90 times minus 10 plus 30. So either you can do that or you can do that. Now, which quadrant does it come to? The most important thing is the quadrant minus 810. Minus 360, minus 720. Oh, sorry. Yeah, I'm correct. I'm going to go this way. I'm looking at you. So minus 360. No, let me do it here. I was trying to show without having to do it. Look, minus 360, minus 720. This is minus 810. And that is minus 900. Minus 810, minus 60 is here. Minus 900 plus 30 is there. So it is in that quadrant. In the third quadrant, A, S, T, C, it is positive. tan 60. 9 is an odd multiple, so tan becomes cot. 10 is an even multiple, it remains as tan. Cot 60 or tan 30, both are 1 over root 3. So to recollect, number 1, express the angle as an acute angle taken away or added to a multiple of 90. Having done that, decide the quadrant, put the plus or the minus depending upon which quadrant the angle is. Number 3, if it is 90 times odd, tan becomes cot, sine becomes cos, cos becomes sine, cot becomes tan, sec becomes cosec, cosec becomes sec. If it is 90 times an even number, sine will remain as sine, cos will remain as cos, tan will remain as, meaning the ratio does not change. Okay? Fine. So that was the purpose of that particular example, to make you revise how to find. So for example, somewhere when you're doing integration or differential equations or some other or equation in trigonometry, you get tan of 90, 270 plus 3 theta. 270 plus is in the fourth quadrant, tan is negative. The 270 is 90 times 3, so therefore minus. But tan becomes cot, so it's cot 3 theta. Minus cot 3 theta. Yeah, something like that. Next, prove the identity. Or they might say, show that. Prove the identity. Sec squared A plus cosec squared A equal to sec squared A times cosec squared A. Whoop. Well, when in doubt, play the trump. What is the trump? Sine and cos. Okay? Why? And it's easier to convert a plus into a times than a times into a plus. So I'll start with the left hand side. The left side. Sec squared can be written as 1 over cos squared. Cosec squared can be written as 1 over sine squared. Take LCM, so it is sine squared A plus cos squared A over sine squared A cos squared A. That is 1 over sine squared A cos squared A, which is 1 over sine squared A times 1 over cos squared A, which is cosec squared A sec squared A, which is the right hand side. Or if you start with the right hand side, write like that, write sine squared plus cos squared, 1 as sine squared plus cos squared, divide each term, you get the left hand side. You can do it this way or that way. Please don't convert into tan. You can do it, but it will take ages. Okay? Right. Or should I show you? Anyway, let me do using tan. Someone says, sir, I can't think of this, but I know sec is 1 plus tan squared, cosec is 1 plus cot squared. Fine. So it's 1 plus tan squared A plus 1 plus cot squared A. What is tan? 1 plus sine squared A over cos squared A plus 1 plus cos squared A over sine squared A. I don't know whether I'm getting into a bit of a problem. Let's take sine squared A cos squared A as LCM. Sine squared A cos squared A as LCM. I get sine squared A cos squared A, okay, plus cos squared and cos squared goes sine power 4A plus sine squared A cos squared A, plus cos power 4A. Now, does that ring a bell? I hope it does. Okay, so I can write this as sine power 4A plus 2 sine square A cos square A plus cos power 4A over sine squared A cos squared A. Okay, nothing wrong. So for the benefit of those who might not see the link, it is sine squared A whole squared plus 2 times sine squared A times cos squared A plus cos squared A whole squared over sine squared A cos squared A. What do you see in the numerator? A squared plus 2AB plus B squared. So that is sine squared A plus cos squared A the whole squared over the same thing, which is 1 over sine squared A cos squared A. So you can do it that way as well. But do you see the amount of extra work you're doing? So stop to think for a while before you apply. That's what I'm trying to say. Okay? Right. I'll take another identity. As I said, I'm just going to revise what all I have taught you. That's all I'm doing. I'm not doing anything else. So, or for example, prove, what example was that? Number 5. Prove, or let's say 4b. 4b is better because I've written 4b in mind. Prove 1 minus cos x over sin x equal to sin x over 1 plus cos x. Obviously, x not equal to 0, x not equal to n pi. Okay. Why did they give that condition? I haven't yet taught you pi. So not equal to 180 n. Because look, if x is 180, xn is 0, this is sine 0, not defined. That is called 1 minus 1 is 0, not defined. Here, if you put x as 180, cos 180 is minus 1. 1 minus 1 is 0. That's why it's not defined. Okay. But you don't have to bother about that. That's for people like me and the examiners know it's mathematically correct. How do we prove this? To prove this, can we start with, I'll show you a unique way of proving it. What the identity? Identity is sine squared x plus cos squared x equal to 1. Can I write this as sine squared x equal to 1 minus cos squared x? Can I write this as sin x times sin x equal to 1 minus cos x times 1 plus cos x? So it is, so sin x over 1 minus cos x equal to 1 plus cos x over sin x. Or I can flip it around, 1 minus cos x over sin x equal to sin x over 1 plus cos x. Hey, that's one way. But here I can start with this, write it as cosec x minus cot x. Oh, there are so many ways you can do this question. But I have shown you that this is one way of doing it. Okay, I can't think of it. No problem. I'll show you another way of doing this. The other way would be cross multiply. 1 minus cos squared x equal to sin squared x. That means sin squared x plus cos squared x equal to 1, which is true. But by writing 1 minus cos x, this as cosec x minus cot x, then multiplying, simplifying, I can arrive at the answer. It will take 2.5 pages, not worth doing. But it will still come because then I'll write this as a multiply top by 1 minus cos x, multiply bottom by 1 minus cos x, open the top, write the bottom as 1 minus cos squared or sin squared, then divide, I end up getting the answer. You can do that as well. There are about 6-7 different ways of doing it, but I mean, my job is not to show off, just to show you the easiest ways of doing these things, that's all, which I have done. Okay? Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.